formation of linear programming problem, LPP, linear programming problem. Formation is a very simple technique. It's not even technique actually, it's based on common sense only. So what I will do is I will just explain a simple example. It's almost a practical example, but I try to simplify that example so that you can understand it better. Okay? Suppose we have a manufacturing unit in Hyderabad. A manufacturing unit in Hyderabad. Okay? Though I mentioned it as a manufacturing unit, basically it's not a manufacturing unit, it is an assembling unit. Assembling unit means, suppose if I have to manufacture or bring a finished product like a car. Generally I give car example which is more easy to understand. Car. So if I have to produce, suppose Innova car. So the possibility is you try to manufacture every part of it, or you outsource the manufacturing components to some other supplier, okay, and then get all those manufactured final finished products and then assemble them, go with some kind of polishing or finishing and outer touches, streamline everything, and then add some profit to that and sell it. Okay? My unit, suppose, is an assembling unit. Assuming that my unit is all about Toyota manufacturing company's products. Okay? Take any two cars from Toyota. Anyone who knows Toyota products? Innova, Fortuner. Okay. Innova, Fortuner. What kind of spelling? Okay. Fortuner. So my manufacturing unit, what I do is I purchase or import parts of Innova product and parts of Fortuner product. So import means I have to spend some money for that. So I have some kind of expenditure on that. So even I will have a kind of a budget to import. There should always be a budget in any business scenario. You will always have certain budget for each and every activity. So for import of these units, parts, I will have certain budget of that. Okay? Assuming that for the parts that I am going to import, on an average, suppose for each Innova car to assemble, there are different parts. All the parts if I import, assuming that it costs me, suppose 10 lakhs. Figures. Don't worry about the figures. Okay, understand what I am trying to tell you. Okay, in this case, let it be 15 lakhs. Let it be 15 lakhs. Okay. Now, this is import of parts. For assembling, remember 10 lakhs is all about for 1 unit of Innova car. 1 unit of Innova, the cost of importing all the products would be 10 lakhs, and the cost of importing all the spare parts of 1 unit of Fortuner car, let it be 15 lakhs. Okay? Assuming that I am thinking of finally generating X1 Innova cars and X2 Fortuner cars, the total cost of, I don't know what is X1 and X2 as of now, I am going to find out those X1 and X2. Now, my target would be how many Innova cars I have to produce and how many Fortuner cars I have to produce for the restricted budget that I have. The budget that I have, assume it to be, what would be the budget? Some K would be the budget. Then obviously 10 lakhs into X1 plus 15 lakhs into X2 will always be less than or equal to, suppose, 10 CR. 10 CR. Are you getting? So the budget that I have as of now for my manufacturing unit is only 10 crores to import all the products. How many Innova, how many Fortuner is not yet known to me, because this is what the budget that I have. To get that X1 and X2, there are certain other parameters that you need to consider also. Okay? What are all those? For example, assembling. To assemble 1 unit of Innova car, the cost it takes, let it be some 3 lakhs. 3 lakhs is the cost of assembling all the units of 1 unit of Innova car, assuming that, okay. See, assembling also will have lot many other sub operations, okay. I am just consolidating everything and putting it as assembling. Now, let it take 5 lakhs in the case of Fortuner. So, I will also have a budget for assembling. So, for assembling X1 Innova cars and X2 Fortuner cars, the total cost, total budget for me would be 3 lakhs into X1 plus 5 lakhs into X2 will always be less than or equal to 3 CR suppose. The total budget for my assembling is 3 CR, okay. You can add some more operations also like polishing or something else, something else, something else, okay. Along with that, finally, I am not taking more operations, I just restricted myself to very simple scenario wherein I have only 2 operations here, okay. Let there be profit. Profit added to each Innova car, let it be 2 lakh. But yes, I am giving 2 lakh for each unit of Innova car. For this, let it be 4 lakh. Let it be 4 lakh. So, what would be for any business scenario or any business unit or entity, what would be the criteria, what would be the objective of this business unit to get profit? So, to maximize profit, it's not just to get profit, always to maximize profit. So, my objective, or we call it as objective function, would be maximization of the profit, let it be function Z, which is equal to 2 lakh times of X1 plus 4 lakh times of X2. So, what should be that X1 and X2 such a way that my profit would be maximized within the constraints that I have here. The constraint that I have is my budget. My budget itself is my constraint. My budget for what? My budget for importing the spare parts and my budget for assembling, or you can add some more other budgets also. My constraints would be this one. Within these constraints, how I have to maximize my profit function for what values of X1 and X2? How many units of Innova, how many units of Fortuner cars that I have to import and manufacture and get this profit so that my profit would be maximized is my objective, is my scenario right now. This entire scenario we call it as linear programming. If you try to put in terms of mathematical symbols, one expression that I have already kept is maximization of my profit function, which is objective function. So this is called objective function. Okay, and what are the constraints that I have? Subject to the constraints, 10 lakh times of X1 plus 15 lakh times of X2, always less than or equal to 10 CR. And then one more constraint that I have is 3 lakh times of X1 plus 5 lakh times of X2 is always less than or equal to 3 CR. Within this boundary, within this bounded domain, I have to find that X1 comma X2 in such a way that my objective function would be maximized. Sometimes we can have the same budgetary constraint, but my profit I can change. Maybe instead of 2 lakhs, I will keep it as only 1 lakh. Instead of 4 lakh, I can keep it as 5 lakhs. That depends upon the business entity there. That you have to decide. The decision makers have to decide about what should be my profit in each of them. So that my objective would be to maximize the profit function, objective function, wherein I have to decide on X1 and X2, which are called as decision variables. And these are constraints. This is objective function. At the same time, again, there is one more thing. I cannot produce negative cars. I have to produce only positive number of cars. That is, x1 and x2 has always, they have to be always non-negative, greater than or equal to 0. This entire thing is called as linear programming problem. The scenario tried to keep in terms of mathematical symbols, which gives us the linear programming problem. These are called constraints, and this is called as non-negativity constraint. Non-negativity constraint. Okay. Now what happens is, by default, if I try to solve like this, x1 and x2 may be non-integers also. Why it should be 1, 2, 3, 4? Sometimes x1, x2 based on the constraints that I have, based on the objectivity that I have, it might be 1.5 or 2.5. And I cannot produce 1.5 Innova cars. I cannot produce 2.5 Fortuner cars. So I have to convert them into integers also. Integer programming. I mentioned about integer programming, right? That integer programming is all about finding that x1 and x2 which are integers, so that my objective function is maximized and still within the constraints that I have. Are you getting that? This is called linear programming problem. You can always take note of this one. Instead of so many zeros, you can truncate the number of zeros also if you want. Just whatever is there, you just keep note of this. That's all. But what I want is, finally you keep note of this one, this particular aspect. So it will be always of the form objective function maximize. Sometimes you can form a linear programming problem. Instead of profit to be maximized, I want, suppose this is loss. Loss I will always try to minimize it. So objective function can be either maximization problem or it can be a minimization problem, depending upon what is the objective. If you put it in the matrix form, it looks like this. If you put in the matrix form, it looks like this. A is the coefficient matrix of the constraints, that is 10 lakhs, 15 lakhs, 3 lakhs, 5 lakhs. And X is that unknown decision variables matrix, less than or equal to. Sometimes, you know, this can be greater than or equal to also. So minimum this much of expenditure I want to incur. Minimum means it will be greater than or equal to. Sometimes exactly equal to also can be there. So the constraints can be either less than or equal to, greater than or equal to, or equality also can be there in constraints. In constraints.